Hi, everyone. My name is Mike Gualtieri, Principal Analyst with Forrester Research, and I want to talk to you today about streaming analytics, sometimes synonymously known as real-time analytics. And really what this means is about analyzing data, finding insights, and acting on those insights in real time. So I always like to start this out from a business perspective. And what are the priorities that we're seeing from our survey data in the business? And you can see here, we surveyed 3,000 global data and analytics decision makers to ask them what they're seeing in their organizations as top priorities. And you can see that improving the experience of their customers is number one, closely followed by improving those products and services. Of course, you also have the likely suspects of reducing costs there, but there's also ability to innovate, addressing riser customer expectations. So you can see that there's a theme there of improving the experience of customers, and the reason for that is clear. Companies want to gain new customers, retain them, increase loyalty, and this is really getting back to something that we've always had, which is personal relationships with customers. Way back when, someone walked into that corner store and that shopkeeper knew you and knew what you needed and knew personal things about you that created a really intense, individualized customer experience. We moved quickly to mass production. We sort of got away from that in favor of mass production. We tried to get back to it with CRM, customer relationship management, by segmenting customers. And now, the reason why we're talking about big data and real-time analytics is now we can use the data and the connectivity of customers to create hyper-personal, real-time digital experiences that are equal to those personal relationship experiences, and in some cases even better because it can scale through the use of analytics. So this whole trend, which at Forrester we call the age of the customer, I just net it out, I call it celebrity, because really what it means is that customers want and increasingly expect to be treated like celebrities. And how do you treat celebrities? Well, we know everything about them, don't we? So if George Clooney walked into the Cheesecake Factory, they wouldn't just give him any old menu. When you walk in there, we all get the same menu. Why? Why can't it be more individualized? George Clooney, they would prepare a menu, they'd understand what he wants. And imagine, too, if he had a wearable device and it even connected to their menuing system, determined that he ran 4 miles that day and therefore would display the Kahlua cheesecake. So these are the type of individualized experiences we're trying to create. But the only way we can do that is with analytics. And it's not just plain old traditional analytics. There are 4 types of analytics that every organization needs to deliver these types of experiences. There's descriptive analytics, and think of that as traditional BI, and that's where most firms have invested collectively billions of dollars over the years to create reports and dashboards. But look at these 3 other types of what we call advanced analytics, predictive analytics, streaming analytics, and prescriptive analytics. These type of analytics are where firms must invest if they're going to be able to create these real-time personalized experiences. Predictive analytics to create models about individuals, their behaviors, their characteristics, what they need and want in the moment. Streaming or real-time analytics to detect that context, what's happening right now. And then prescriptive analytics to adapt, to figure out what to actually do about the context that was just detected. And this whole idea of advanced analytics is surging right now. If you look at this data where we compared adoption of different analytics technology between 2014 and 2015, whoa, I mean, it's unbelievable. Look at the momentum. I've circled sort of these lower quadrant, this lower half of the graph. You see predictive, location. Streaming analytics went from 24% to 42%. So there's an enormous amount of adoption and momentum on these advanced analytics topics. And that's actually good for those of you who aren't using advanced analytics yet, because, you know, with only 43% adoption, 42% adoption, that still means that most of your competitors haven't started. So this is a really good time to get into these advanced analytics. Now, analytics is nothing without data. And we often talk about big data, but all data is born fast. There's always a transaction that occurs. There's always a sensor. It's always born fast. Some say that data is the new oil, and I believe that's far too limiting. It's more like the sun. It's virtually limitless. It's being created constantly, and we have to capture it. And most industries have much more data. It's all the transactional data from all of their business applications, and many enterprises have a portfolio of hundreds of business applications that all originate data in a moment. There's usage and behavior data from mobile and web, social media, log data, IoT device data, and other forms of data that you can buy and sell. So there's plenty of data out there, and in this industry, and enterprises have plenty of data from both internal and external sources. You can see here we ask companies to estimate what is the size of the data stored within their company, and you can see there's a big range, 100 to 500 terabytes, greater than 500 terabytes, but there's plenty of data out there for analysis. And we also ask them on the right what percentage of that data is available from internal and external. And you can see it's roughly 50-50. So there's plenty of data, and there's plenty of data from both internal and external sources to analyze. And all of that data is born fast, and you mostly think of data ending up in a database, ending up in a data warehouse, ending up in a file system, ending up in Hadoop. But when it originates, it's all the result of some moment in time, some event that is occurring. So all of that data is born fast. So don't think of data as sort of historical anymore. You have to think of it as real time. Problem is, all data is born fast, but the analytics is usually done much later. You know, the data is generated in an instant, and then ultimately it finds its way in databases, data warehouses, Hadoop, and then it's analyzed later. Why? Why do we have to wait a day, an hour, a month, a week to analyze that data? Why don't we analyze it as soon as it is born, as soon as that data originates? And when we can do that, we can capture what I call perishable insights. And perishable insights can have exponentially more value than the traditional after-the-fact analytics. And if you think about the word perishable, what does that actually mean? Well, it means just what it says. There's some analytics that are only good right now. When George Clooney walks into that restaurant, there's a certain set of analytics and content that comes together, and you can only act on it right then. You can only display that clue of cheesecake. And there's many other applications for perishable insights. For example, fraud detection. I mean, we could capture all the credit card transactions, all the electronic payment transactions, store them in Hadoop, and then analyze them tonight or later. But those insights, you want to stop the fraud right now. That's a perishable insight. There's many financial companies that are analyzing the social media feed for real-time insights on what stocks may move in the moment, right? It doesn't matter if, you know, Mr. or Mrs. X said something about a certain stock. You can't act on it tomorrow. You have to act on it now. Again, a perishable insight. Increasingly, there's wearable devices like the one that this baby's wearing that monitors the baby's position and the temperature. So it's a much more sophisticated baby monitor. You don't want to just collect this information and then analyze it later. If something's wrong, you want to know about it right away. Again, a perishable insight. And even automobiles are getting smarter. A typical automobile might have 250 sensors in it. And one auto manufacturer is working on, if there's tire slippage, if it detects tire slippage, it can then broadcast to the cars behind it, 2 miles behind, warning of slippery conditions. Again, a perishable insight. And location analytics is very big here as well. What if these girls were shopping in an outlet mall? What offer or not should you make to them when they're in the proximity of the store? That's a perishable insight that has to do with the location. So there's many, many examples of perishable insights. Final example I'll give you is Pandora or Spotify. There's sensors, an accelerometer. What if the Pandora app could detect when someone's jogging and then play music in their stream that matches the tempo of their run? Again, a perishable insight because you can only act on it when they're running. So perishable insights are great, and we need to develop applications that can take advantage of perishable insights, but there's an age-old problem with this, and there's technical challenges. And survey after survey that we've done, we've asked, what are the technical challenges impeding you from processing and analyzing more data, not even asking about necessarily real-time or predictive. And these are the answers. And none of these will surprise you. Difficulty integrating data from multiple sources, always a problem. Data volume increasingly large, creating the data models, preparing the data, too many formats, and difficult to access from multiple sources. So that begs a question, how can we solve, we need more types of analytics, how can we overcome some of these technical challenges? And streaming analytics provides two benefits to overcome some of those challenges. And the biggest one is that you can actually prepare and process that data in stream. You don't have to wait. You can process it immediately. So let's look at these two concepts that are very familiar these days. The concept of a data lake or a data warehouse versus the concept of a stream, real-time stream. So a lake can ingest data in real time, because you can have connectors and just load that file system, say in Hadoop. So can streams, right? Lakes can certainly accommodate multiple data sources and formats, so can streams. Lakes typically store that data in a data warehouse, Hadoop, or file system first. Streams, on the other hand, can analyze that data in the stream and then be routed to a data warehouse or Hadoop or file systems for later additional analytics. But the key here is, and this is where the key difference is, that data can be analyzed in stream. Lakes, you typically run batch analytics. Hadoop and Spark are batch platforms, and those batch analytics can run monthly, weekly, daily, or hourly. For historical insights, streaming analytics, those real-time analytics, runs continuously with sub-second or multiple-second immediate insights. And the analytics you do in a lake are after-the-fact analytics, and those can be used to adjust strategy, tactics, or some sort of future actions. Whereas stream, those insights can be used immediately to take actions. Those insights are used to find those perishable insights and to take action on them in real time. So when you're thinking data lakes, also think streams. And I'm not saying here that you just need streams, but I'm saying a lot of the things that you think about doing in a lake, you can actually do real time in a stream. You need data lakes and you need streams simultaneously. Let's go a little bit deeper on what we mean by streaming analytics. And again, I say streaming synonymously with real-time analytics. So streaming analytics can detect and act on those perishable insights. And the definition that we use is streaming analytics. It can filter, transform, aggregate, enrich, analyze a high throughput of data from multiple live data sources to identify interesting patterns, context from IoT, from whatever data is flowing in, to detect those situations, and then automate immediate actions in real time. And a lot of people get tripped up on this whole term real time, because what does that actually mean? Well, it means different things in different businesses. So if a customer walks into a shopping mall, real time can mean a few seconds. A shopper clicking on an online ad, that can mean, maybe 100 milliseconds. A stock price rises, that could be microseconds. So real time just means business time, but you need these platforms to be incredibly fast to handle this. Now, thinking in streams is very different from thinking in data lakes. There's two core capabilities that streaming analytics platforms do, and this is very important, especially the left side. Well, they're both important, but the left side might surprise you because it's about real-time ETL. The typical analytics process is to acquire these sources and then to do ETL. Okay, and even if you load the data directly into Hadoop, you still do some ETL. You're just doing it in Hadoop. Why wait? Why not do it real time? Streaming analytics have the capabilities to ingest, filter, transform, normalize, link, and enrich. So you can do in-stream ETL. And then if you look at the right side, these are the core analytics capabilities to correlate multiple streams, location, geofencing, time windows, temporal pattern detection, business logic and rules execution, and then action interfaces take action on those insights. So these are the core features of streaming analytics. Let's look at how this might be used in a real life situation. Let's just pretend that we're an online retailer and we want to sell more motorcycle helmets and we want to optimize our profits. So we can use 4 of the key streaming analytics: temporal pattern detection, windows, business logic, and action interfaces. So look at the left on the temporal pattern detection. Suppose one of the rules, the analytics we want, is when has the user viewed at least 3 products, including at least 1 helmet. So they could view 2 helmets or 1 helmet, gloves, other safety products. And once we detect that pattern in real time, then we want to display the most profitable motorcycle helmets because we think that this analytic tells us that they're interested. Okay, that's interesting. But now let's add an addition to this, which is a time window. What is the real-time daily sales total of the motorcycle helmets? Now, the reason why we want this is because we might want to adjust the price up and down, because remember our first goal was to sell more motorcycle helmets. Our second goal was to maximize profitability. So if sales is trending lower than usual and this customer is price sensitive, then dynamically lower the price. Likewise, we could raise the price. So all of these rules and these analytics are expressed and executed and delivered in that streaming analytics platform, and it gives you an incredible breadth of analytics, rules that can all happen in real time for multiple users at once. Try doing that with plain old SQL on real-time data. You know, if you're really good at SQL, you can probably implement what I just showed you on the prior slide. But if you really start to think about it, you can't do it in real time without doing polling, and that's not scalable. So if you're interested, just take that exercise on yourself and see what you come up with. Ultimately, you're going to need a continuous analytics to action architecture, and streaming is a key component that makes that happen. So what are the requirements? What are the things that you need to have in a streaming analytics platform that's going to give you this real-time capability? Well, look at the left. You can see at the top, these are the real-time platforms going down to the batch platforms. So streaming analytics is the most real-time of all platforms, and it's often supported by an in-memory data and compute grid, a clustered database, and you still need general-purpose data processing to do things like predictive modeling after the fact. And that's often done these days on Hadoop and Spark, but also data warehouses. So, the individual requirements you need is all streaming analytics platforms are absolutely in-memory platforms. We don't say an in-memory streaming analytics platform because streaming analytics, it has to have memory. That sort of latency for complex data and analytical operations, and many of them are stateful because the time windows, it has to be an in-memory platform. And memory, by the way, roughly is 58,000 times faster than disk. It has to be a scale-out architecture to handle any amount of born fast data. Going back to the motorcycle helmet example, we just had rules about one person. If they click on 3 safety products within a 1-minute time frame, imagine if there's thousands, tens of thousands, or millions of rules and customers that you have to access at that time. So it has to be able to scale out to handle large amounts of data like IoT, but also large amounts of user. It also has to provide high-level streaming operators to build complex applications very fast. There's a number of open source platforms. There's both open source and commercial platforms that have emerged. The open source platforms often require lots of programming to do it. Commercial platforms often provide high-level streaming operators. So it's not just about the enterprise qualities of scalability and performance, but it's also about the speed and ease at which you can develop the applications. Of course, they have to connect seamlessly into existing architectures, not just to acquire data sources and sources of events, but also for the action interfaces as well. And as I said before, streams replace a lot of what's done in the lake, but it doesn't replace everything that's done in the lake. So the streaming platform also has to feed batch clusters to process that historical analytics and build predictive models after the fact that's going to later support the real-time analytics. And finally, since we're talking about insights to action here, the platform has to have rules. You have to be able to embed rules and then call out to other applications to initiate actions. So if we bring it back to the business priority, you have to develop real-time, hyper-personalized customer experiences. And the only way to do that is to have those 4 types of analytics and to think about the perishable insights within your organization. Start with streaming because that's the most real-time of all the platforms, and you can see there's still an enormous amount of momentum on that and all the other advanced analytics platforms. So only the real-time enterprise, only the real-time company is going to be able to compete and win in the age of the customer. So make sure that in addition to your business intelligence, make sure that you also have the 3 forms of advanced analytics: predictive, streaming, and prescriptive. So thank you very much.